Well, welcome everybody. As you can see, our speaker is remote. When we started this year, we thought we'd set ourselves the challenge of trying to do a few new things, and this is certainly going to be one of them. I'm trying to get myself in. Philip, I met Philip last year at another session, and in London, and he was talking about enterprise architecture and patterns, and I thought this sounded a really interesting subject, particularly as a large company like BT's had to take on some quite large sort of thinking around this whole area, and Philip kindly agreed to come along and speak this evening. It's the first time we've ever run anything like this remotely, but I think it's also quite useful. I was talking to a couple of people earlier. If it works, that we could actually attract people from other countries. And as we're recording it as well, it not only allows us to attract speakers from other countries, which isn't yet another country, although who knows what would happen with Brexit, we might have all split up. But also maybe try it the other way around and start to allow an audience in on the actual technology as well. Is there anyone logged in other than Philip to this? No. Just Philip? Yes. Right, so you're on your own. That's good. So you're not having to handle an audience other than what you can see. So Philip, perhaps I can hand over to you, ask you just to perhaps give a bit more introduction to yourself, and then we'll run for about 40 minutes, however long it takes, and then do some Q&A.
Great.
Thanks very much.
Thank you, Lorne. Okay, thanks everybody. It feels somehow appropriate working for BT that we are using remote technology as it's supposed to be our business, and indeed conferencing is one of our product lines. So just a little bit about myself and where I fit in within BT. So I've been with BT for a good number of years now. I'm approaching 30 years, which is amazing. I did have a short life before that. And I've always flipped between IT and operations. I've spent times on both sides of the fence. And I worked up from designing and coding as one does. In those days it was in assembler up through Pascal, and then quite a long period of time working on large-scale network and service management systems, so call center systems, systems running for our global networks and that kind of stuff. So, and about 5 or 6 years ago, I made a sort of horizontal move, and I moved into our enterprise architecture group. And there's about 9 or 10 of us in there, and we cover all of the IT across all of BT lines of business, and we do so architectural governance, which is really making sure that the designs are moving us towards the target architecture. All of the architecture assets, and managing the databases and the lists of all the applications and infrastructure, and working with the business units on agreeing their roadmaps and investments and encouraging them to invest in technology that moves us towards a target end state of architecture. So it's kind of where we fit in. We don't slavishly adhere to TOGAF. I'm not sure that anybody really does, but we do indeed follow that as a general framework for our architectural work. So within the architectural team, I lead a smaller sub-team around data architecture. So we own things like enterprise data model. We do a lot of service-oriented architecture, so we do payload definitions. And we do a lot of general education and helping out solution designers when they're building their designs to make sure that they are compliant with the data architecture. And also, some of you will know BT spends a considerable amount of money on research and development, and the guys on the floor above me are in our R&D team. And that's really where the genesis of our big data came from. If I switch on, hopefully now, and attempt to show a slide. So this is sort of a timeline slide. 2009 really was when BT research colleagues came to me and said there's this thing that we're researching called big data and Hadoop, and the business seems quite interested in it, but we don't know how to get it into production because our research teams don't run production systems and they don't have the security and support wrap that we do in our production data centers. And really what I'm trying to show on this slide is, this is, in my opinion, and several others that I've spoken to, this is kind of not the first time we've seen a wave of a change like this sweeping through the industry. I would argue that this is probably the third one. Those of you who worked on mainframes will recognise a similar pattern where they started out doing batch type applications, which is in telco used to be monthly billing, and gradually moved to interactive type applications. And indeed, we still have mainframes in our production estate today. They're still running some fairly important parts of our estate, and so, you know, although we don't spend a lot of money, they're still there. And then for the last probably 20 years or so, since Cod and Date brought us the relational database management system, and we figured out how to horizontally scale our applications by having you know, N2 applications with a web server layer, an app server layer, and a database layer, and scaling out those layers. That's combining that with service-oriented architecture is where we've been for some period of time. And this new wave around big data, which is a fairly loosely defined term, I think what we'll see is that the current paradigm will start to peak. We talk about peak relational and peak mainframe, and we'll start to see that increasingly our data is being stored and processed on big data-based systems. And if you look at what happened, the pattern repeated itself again in that the early phase of Hadoop was a very batch-oriented system, so anybody that knows it will know it basically started out doing what's known as map reduce. That's an incredibly slow way to query data and process it, and gradually it's starting to speed up to interactive scales. So we've seen a huge number of SQL parsers and query engines, and indeed we're now starting to see software packages such as Apache Spark and HBase providing us very low latency query type solutions. So, and the little annotation along the bottom there is really showing that our research teams, as I say, started in about 2009. 2006 was when Hadoop was first released. It's just celebrating its 10th birthday, as I'm sure some of you will know. And we went into production with a big data platform in 2014, so that's just celebrated its second birthday. And that's basically what we are, the patterns that I'm describing to you this evening is what we are based on. So I think it's worth just considering what's changing, and you know, there are many different aspects to this, but I've tried to distill a couple of things around what's changing in this space. And something a lot of vendors don't talk about, and as a user organisation, you know, this is probably the larger part of what's changing for us, is the economics and the scaling are changing. So we're now dealing with an almost entirely open source stack, right from the OS right up to the clustering system. So the Apache Software Foundation brings us the open source licensing around that. Now, not many organizations are as big enough as Facebook or Google, or indeed the likes of LinkedIn, where they can run large-scale open source teams. So just in the same way that we don't support our own versions of Linux, we don't support our own version of Hadoop, and we do use enterprise Hadoop. We're currently with Cloudera, but we know that if we needed to, we could switch vendors. I think the other big trend.
Hang on.
It's the move to cluster computing. I'm sure many of you have seen that photo. That's a photo of Yahoo's 4 years ago. They're one of the very noted users of the Hadoop stack. So that's the ability to scale out has been the big change. Is that, you know, we know that our cluster is a really tiny cluster by big data standards, only less than 100 nodes on our internal cluster. But we know that if we wanted to, we could scale it up to, you know, the sort of figures that people are talking about is several thousands of clusters, servers in a single cluster. So the whole business of scalability, which has been a very dominant part of the design and investment decision, has really almost evaporated overnight. So that's kind of the economics and the scale out bit on the left-hand side, but the more intriguing bit is what's happening on the right-hand side, and I'll try and explain that diagram. So, and you can really think of it in terms of the way that we've been doing analytics and business intelligence probably for 10 years or so. It sort of got down to a point where we end up with this deadly embrace with the business, where the business says to us, well, we want some data on the customer orders, and we say, well, what data do you want? And then they say, well, what tables have you got in the warehouse? And we say, I don't know, we're going to do a feasibility study, and you end up with this 6 months, and you finally agree to specification for a report, and you deliver it, and by that time the business opportunity's moved on. So it's that need to engage and formalise the delivery cycle very early on really was frustrating the business. But we move to a different pattern when we start to move to the big database stack and Hadoop clusters. Is that what we have at the top there is a couple of silos. So a couple of examples that we're dealing with, obviously we deal a lot with call detail records coming out of our networks and network mediation systems, and we're enriching those with things like customer data or network inventory. We've used this technology a lot to understand the copper network in a lot more detail. A lot of the systems that we have related to that are quite old, and working on them is hard. So we take raw data out of a couple of silos, let's say a test database, a system with test results on, and some customer data. We just land those in flat files, and we ask the application teams to build us an interface that downloads a couple of tables and puts them into straight flat files. And we don't really spend a lot of time on the schema design, so that at the bottom previously we might have spent several weeks or even months doing an end-to-end design, doing entity relationship diagrams, working out all of the keys. But what we tend to do now is when we get an urgent request from the business, we just land the data from 2 or 3 systems into the cluster, and then we'll focus on the business keys. So we spend much less time worrying about physical schemas, much more time worrying about a few very important keys, so things like billing account number, service identifier, home hub identifier, so things that allow us to link those data sets together and do those joins. And so actually we end up doing a lot less data design, and this is what's known as schema on read. It's kind of, instead of doing all the schema design up front, you just land the data, and then once you've got the data into some files, you start to join the data up using a few keys. And you also, at that stage, you're doing a lot of work on data formatting, data quality, what's known as data wrangling. But what we find is that it's way faster. So we've run projects now where we can achieve very large-scale data integration in a matter of days, whereas previously it would have taken many months to do that. So that leads the business to getting a faster insight. We recently did, last year we did a project around analysis, and we didn't have enough spare capacity in our data warehouses to build a scoring model, but by downloading several billion CDRs onto Hadoop, and then playing around with them in a scoring model, we were able to identify nuisance call sources in the network. So this, I've got 2 versions of this slide, and this is the sort of thing that I do all day long for these slides like this. And this was the first version of the reference architecture that we produced in 2013, and the later slide will show you the slightly simplified abstracted version. What we were trying to get across in this slide, and this is about that architectural thing of having a vision and using the presentation of that vision to sell it to the business, to sell it to different stakeholders. So the sort of patchwork area at the top of the sort of pink, green, and blue represent our existing systems. So those are our operational applications. I've only shown 3 or 4. In reality, we have some 2,118 different operational applications. And And typically they're running on a private cloud. We're moving most of our internal applications onto our own virtualized environments based on VMware. And indeed, the enterprise architecture team run the business as usual application governance that's around that. So registering designs, registering changes to those. It's a pretty big deal if you want to create a new application, and you get a lot of brownie points if you get rid of an application, because that represents simplification, and in our environment, simplification is a good thing. Some of those applications are dual-sited, so that top red one is shown as having 2 databases, typically in 2 different data centers. And then on the right-hand side, we have the business intelligence and data warehousing applications. And each of our business market-facing units, so BT Consumer, BT Wholesale, BT Global, tend to have fairly large line-of-unit data warehouses that are sucking data out of those operational apps on the left-hand side via a whole range of technologies, file transfers, some golden gates. We're doing CDC-type replication. And that's where that sort of slow process of producing those MIS-type reports has been going on for a long period of time. And so what we said, well, what we're going to do with the big data platform and that's represented by the big yellow dustbin at the bottom, so the HAS environment, as it's known, or Hadoop as a service. We'll introduce, the first decision we said was we wanted to have a single physical platform for the whole business. And there was quite a bold move, and we had a number of business units early on in the piece that said, we like this big data thing, but we would like to build our own cluster because we like to do our own things. And so we spent a lot of time arguing with business unit CIOs and explaining to them, look, there's no, we explained to them that clusters are supposed to be big and you get economies of scale. So please, can we not have everybody building a 10 or 20 node cluster? Can we just have one, and we'll just scale it to as big as we need to be. So that's why it's important for us to get across that vision that although we have many Oracle and relational databases, we're only actually going to have a single physical big data infrastructure for the entire company. And then we have a sort of a number of layers within that layer. So and it depends on which way the data is flowing to the business, which layers it goes through. But the classic thing that we're doing, so for that example I explained earlier, where we had data in existing relational databases, but we needed to join it quickly, or there wasn't enough horsepower left in those systems to do that analytics, then we would extend the applications down into the big data platform, into that file layer. So that's that kind of pattern I explained to you, where we just land those, we suck a few tables out of the relational databases and land them in a file layer. We would then typically look to expose those into that data and code layer, and there's a couple of different web patterns. If it's an ETL offload, so that red application is pushing some data down, it's doing a transform, and then it's pushing the data back up either into its standby site or back into the main site. So that's where we're offloading heavyweight processing from a relational database and pushing it down into HAS. We're doing it with the MapReduce code down in that data code layer, second layer, and then we're pushing the results back up into the operational application. So, and that's a pattern you'll see used in internet companies. So, people like Amazon would use that for people who looked at that also looked at this in their shopping. They would pre-compute recommendations and push them up to the web servers. And so it's a very similar pattern. It's just set in an enterprise context. Then the data science and the data joins of the agile BI or data discovery driven BI is where we start to say, well, now we've got the data landed in the cluster, we then start to expose it, and we build that exposure layer, or what's known as the enterprise data model or table layer, and that's where we'll take some of those tables, we'll typically rename them and relabel them to make them easier to understand in a business context. And then we'll expose them to that sort of set of sandpit type tools on the right hand side then, shown in the orange, through tools such as Hive and Impala, where people can start to do those join constructs. And that's where we start to get a lot of value there in terms of doing the data discovery and data science type work. And we have a whole range of data consumers on the right hand side, and that's where we've introduced some new analytics governance shown at the top. We We didn't want people just kind of running riot on the cluster, so we run a weekly governance board. Anybody in any line of business can bring a project to the governance board, but they have to register what data sets they want to get access to, what the purpose is they wish to do with that access, and how long they're going to take to do that. So it's typically whether it's a 1 week or a 3-month project, and then we'll bring them back for review to see what they're doing. So that allows us to handle things such as personal data privacy issues, if there's any internal security we need to deal with. That's where we kind of trigger a review of the work on inbound. They will then get access to a sandpit, and then they can use a whole range of tools that we have available. So we're an Oracle shop, so we use Oracle DI, Oracle Data Integrator. We've invested in some tooling that's native to Hadoop, so we use a thing called Datamere, which allows us to do a lot of data wrangling and profiling. We have within the research teams a number of data scientists. We're quite lucky to have those in-house, and they work in programming languages such as R and environments like RStudio. So they're building scoring models, predictive algorithms, recommendations, a whole bunch of stuff around that, very, very specific to the project they're working on. And then, of course, we have our existing BIs and business analysts who are using more traditional tools, things like Oracle Business Intelligence, which is the reporting and dashboarding environment. We have a little bit of Tableau that we've invested in. But what we also have found is that some of those environments, tools don't provide the visualizations that we want. And so we've actually developed a number of visualizations for ourselves. So we've developed something called Saturn, which is around security and threat analysis. So cyber assurance is a big business for us. And so we have some customized data visualizations to allow you to look at large volume, large-scale attacks onto networks and understand the threat situation. Aperture is one we've developed which is around process analytics. So we know that our customer experience and our consumer division is not all that we would like it to be, and we spend a lot of time trying to understand where we have broken processes. And Aperture is a way of mapping out and ingesting very large scales of events and drawing pictures of process flows to understand where orders are getting stuck and broken. Just then on the left-hand side, like most applications, our business is very keen on public cloud-based applications, so things like Salesforce, which has significant traction in the application. And we find we have a problem with those type of cloud applications in that we end up with data stranded in the cloud and nowhere to bring it back into the enterprise. And we've agreed a pattern whereby we'll set up landing areas for cloud-based applications and allow them to repatriate their data, so we can integrate it with the rest of the estate. And then quickly the bullet points on that one. So the infrastructure is owned by the data center team. So this is a little bit different. A lot of people set up their Hadoop clusters within the BI or data warehousing teams or research teams. In our opinion, the big data platform is no more than a new type of data storage and data processing environment. So the actual clusters are run by the data center team. We pick out in our review, in our business as usual governance, we pick out batch and high velocity and variety applications and steer them towards using the big data platform, whereas previously they might have used some other vendor technology. We've done a cost analysis of this, and we know that this is about pound for pound in the terabyte per terabyte cost. It's probably about 20% the cost of the storage in our private cloud, which is very expensive. So just using this in preference to our private cloud saves us money. We use the existing application IDs, our register of applications. So whenever you create a sandpit in the big data cluster, it's linked to the only application. I'll go on to that in more detail. And as I said, anyone can apply for the governance. So this is a platform we launched in February 2014. It's a 50-node, 2 petabyte cluster. Those guys in the middle are the existing Linux DBAs. We brought them in and trained them up into running Hadoop admins. They work quite closely with the research team who run their own clusters. We ran a series of workshops in 2014. We worked with partner Cloudera. Cloudera built effectively the first half of the cluster, and then these guys built the second half, and they've been running it for 2 years now. They've written most of the automated provisioning on the front end themselves. They've written a bunch of capacity management stuff themselves. So we offer it basically as a service that applications consume. It's integrated with our Windows Active Directory, so it's secured. It has the same Kerberos authentication that our Linux servers do. And it's pretty much self-service provision. It's not quite automated flow-through in the way that Amazon is, but it's very close to that, and we could automate it if we wanted to. And we did indeed made the finals for the awards a couple of years ago. Just to give you an idea of how that's grown, so over the first year it was quite slow. The two lines are, we keep the OpenReach on a separate physical infrastructure. We have a regulatory compliance to keep OpenReach systems separate. So that's the upper line, and the lower one is what we know as the rest of BT. And we're something like just over 200 instances. And you can think of those as being really like Linux containers. And typically a project will have between 2 and 5 containers, so a couple of dev environments, a test environment, and maybe 1 or 2 production environments. And also mixed in with that are the end user sandpits. So we have a mixture of operational applications and end users on the same platform. This is the architectural diagram that we're using at the moment. It's a slightly simplified version, although it contains the same basic components as a rather more complicated diagram. The green area represents our private cloud, and we run our operational applications, so CRM, billing, middleware, all that stuff runs on the private cloud, as does our analytics, but they are obviously in separate Linux virtualized environments. But when they come to HAS, they run on the same physical infrastructure together, and allows us then under role-based access control to share data between those blue boxes. And we primarily customize our applications in terms of commercial off-the-shelf applications that we would purchase from Oracle or whoever. Applications we write ourselves, so BT applications. We actually are probably tending to increase the number of applications that we develop ourselves. And then the public cloud or SaaS-based applications, so the sort of Salesforces, and there are some marketing ones that we use. And we have this concept of HAS extension, that -HX, where we end up, the target is that we end up with more raw data in those extended applications that really what are in many cases archiving databases for those databases that are running on the private cloud. So typically the ones in black will be a relational Oracle database running on virtualized Linux, and then we will use a number of tools we'll come on to push the data down into a logical database, a Hive database on the HAS platform, and we refer to that as a -HX. So whatever your application is, so you say I've got we had one we were looking at the other day called Genius. It's a billing application. So when we talk about it, we talk about, well, that would be Genius HX. That's where the data will be, and that's where the analysts will go, as opposed to just Genius, which is the main application running that the business knows and loves to know. Also shown on there, obviously this doesn't mean we're abandoning our service-oriented architecture, and SWS is our service software services, and the intent is that we will replumb a lot of the back end of our server services to read our enterprise data models off of the data stores on the Hadoop platform, and that will allow us to effectively offload a lot of read queries off of the operational systems. But write access will still have to go back to where, if you're changing the current state of an entity like a customer or an order, then you do that via the application. So this is where we get this concept to end up of an enterprise data hub, or in some cases we like to call it a data lake. I'm not that keen on that term myself. And we use a number of simple patterns, which I'll go on to help application teams that have known nothing about Hadoop, but suddenly have been asked, you need to make your data available in HAS because there's some analytics that requires it, and we're going to join it up with these other sets of data. Or we're doing an investigation to how a bit of the business works. The other thing that we found that we can do is produce higher resolution data sets that span longer time periods. So as I said earlier, we had a number of our systems, or average age of our systems applications is, most of them, 60% of them are in excess of 7 years old. There's 7 to 15 years old is the typical lifetime of our applications today. So managing end of service life is an ongoing challenge, sort of database versions, OS versions. By pushing the data down into this large-scale, cheap, scalable storage infrastructure, it allows us to actually keep the raw data for, in many cases, the COTS application or the BT application can only keep data for 90 days. And the business, so we'll actually would like it for 1 year or 2 years. So obviously, we have a lot of network outside, and it's subject to weather, and so we have weather patterns. So we like to see how does this winter compare with last winter in terms of the number of field engineer visits that we had to do and that kind of stuff. So we do a lot of that sort of analysis. So that's kind of how we describe our reference architecture today. I thought it might be of interest to look at how that maps onto Oracle reference architecture. So I was to say, we're largely an Oracle shop. We're their largest European customer. So we're always looking at their reference architectures. So really what we've done here is the grey on the background is a standard straight lift from the Oracle reference architecture, and the sort of coloured animations are overlay on top of it. So the sort of data warehouse then is that layer of staging layer, foundation layer, performance layer. What we're doing is we're extending those operational systems into the yellow box, into that Hadoop layer. And that often is for just for information lifecycle management or data quality work or ETL offload. We also take the metadata down there as well, so we share down as much as we can of the data dictionaries. And then we, in the foundation layer, we're starting to experiment with new ways of paradigms of building warehouses. So instead of doing star schemas and dimensional analysis, we're looking at some new techniques such as data vault, which allow us to structure the data store in a slightly more flexible way, so we don't have to rebuild the dimensional cubes all the time. And indeed, along the bottom, we start to see streaming applications which are entirely existing within the Hadoop platform. So we're sort of re-engineering some of our existing applications, so such as things like clickstream analysis, which we've done for a long time, but starting to build that as a more of a real-time application which can integrate with the rest of the estate. And the analytics team is that purple box, so they're still doing what they did, so it's still the BI guys that produce the alerting and dashboards, but they're now helping supply these advanced type analysis and data science type capabilities. Okay, so that's all well and good, and that's what the architects would like to achieve, and the business says, yeah, we like the idea of self-service. Now we have the problem, the fact that we have a couple of thousand applications and hundreds of application teams, I think approaching 9,000 offshore subcontractors, plus our own teams, plus this year 280 graduates that know nothing about Hadoop. And so we have a massive skilling and training exercise on our hands. We're not big fans of using services work. We like to do our own work. And so this is where the HAS cookbook came from. We needed to accelerate the adoption of this platform, but we also wanted to do it in a controlled way. So we didn't want everybody rushing off to go, oh, I think I'll try and build myself a key value database. We wanted it to be done in a controlled way that we can still secure the data and also deliver SLAs. So we sort of styled it loosely on the O'Reilly cookbooks. The current HAS cookbook runs at about 50 slides. I think it's, last time I looked, 15 patterns. We update it on a quarterly basis and we publish it at a nice easy URL. snip.bt.com has cooked. You can't get to it externally, but anybody internally can get to that and download that deck, and whenever we do training, that's where we point folks to. And then broadly in terms of the contents, so there's a lot of intro stuff, so some of the stuff I've talked about already. We talk about the service, so that tells an application development team how do you actually get onto the platform, what are the features you get, and so that's a bit like if you go to Amazon Web Services, it will tell you how you order S3 storage and that kind of stuff. Also tells you the governance you need to do, so it tells you what you can and can't do. It tells you which forms you need to fill in and what workflows and whose approval you need to get to proceed with that work. And that's largely changes to existing governance. We haven't created a whole new overlay. We've sort of tweaked existing workflow engines to handle this. And then there's a number of patterns that are designed to be quick start things that say things like how to extend an existing application into HAS. So that's the most common use case we have. So that explains who's responsible for which bits, because there's a common misconception that says, oh, okay, it's all going to be done by some magic big data team, and they're going to look after all of it, and I don't have to do anything. And actually, this is a distributed model where the data, the extended application, the bit that extends into the cluster, is still the responsibility of the application team. So the support group, the developers, the designers, and the architects still have to worry about their data when it's down there and design their schema and support the data if it's not flowing down from the relational database. So we have a number of data transfer patterns. So there are lots of different ways that you can transfer data to a Hadoop cluster. We only support a handful that allows us to meet the variety of situations that we find. So, and that goes everything from an IBM ZOS mainframe with an IDMS database on it, through Linux servers, through various other sort of Windows-based PCs. So that's a data transfer. We also have a data archiving pattern. So a very common use case for us is people saying, Her Majesty's Inland Revenue now want us to keep a 7-year history of all back calculations because of people selling CDs in the Channel Isles. We now have to keep that data for longer. We don't want to keep it in the warehouses. The operational databases don't want to keep it. So we said, well, look, this is how you do a data archive. And we explain to them how you design your schema, how you flatten your schema on the cluster, and then also how you access the data in that schema via the standard UI. So you don't have to develop any UI, you just have to develop the reporting schema. I talked already about the public cloud data repatriation model. So that's ones where when the business goes off and buys a cloud-based app, we say, well, you're required to make sure that the vendor has a bulk API that we can use to suck the data back into the company so we can have a complete set of data. The data governance and data discovery across analytics, I should say RBAC, role-based access control against application. And so one of the light bulb moments we get with business people is when we tell them that you can do a join across 7 different systems without having to ask any of them to do any development or testing work. Providing you've been through the governance process and you know what business keys you want to join the data on, you can just effectively join up arbitrary applications if they're extended into the cluster. But that does mean that we have to have additional data governance to make sure that the business owner of those applications signs that off. I talked about ETL offload, so that's a common pattern where we explain to them, okay, this is how you land your data with a transfer pattern, and then this is how you write pig scripts or Hive scripts, or this is how you use Oracle Data Integrator to process the data once it's landed on the cluster. And after a little while, we also found we needed to document some anti-patterns because people were doing silly things. So one of the things that we found people starting to do is what's known as jump the perimeter. So what they would do is alongside the cluster, they would install their own Hadoop client stack, and they would start to try and connect directly into the core infrastructure. And this would nearly always fail because of the Kerberos authentication. But we had to explain to people that's not what you're allowed to do. You're not supposed to do that. you're supposed to go to what's known as the edge nodes, which are the declared exposure points for the platform. The other thing, which was an occasional thing in terms of solution designs, is that people would often draw a box and write Hadoop in it, and then that is it, and sort of sprinkle fairy dust on it and expect, okay, that's where all the big data magic happens, now my design is done. And so he said, you're not allowed to draw boxes with has in and lots of lines going into it in your solution design. So you need to think a little bit more nuanced about your solution design. And the other final point there is about unsupported features. So anybody that's looked at a Hadoop stack knows that there are lots and lots of different features, what's known as the zoo of things. So, and not all of those features we support on our production platform. So we currently don't support HBase as a key value store. It's partly a skill and partly a capacity issue. It's in our roadmap, but so we have to make sure that people don't build into solution designs so they're committing to the business to use features that are not available. So all the latest generation of stuff around Spark and in-memory processing, we won't have in production probably for another 6 months yet. So that's the kind of story of the cookbook and the patterns associated with that. So we'll go on and look at one or two of those. This is example one. This is the kind of basic one, what's known as the has extension. So I'll just unpack this diagram a little. So the blue box labeled app 654.322 WCA. So that app number is a number that we register in our master application inventory. There's a whole set of governance around creating that. And then this one happens to be a CRM application used by our wholesale division. And so the couple of boxes up there, server 1, server 2, so I've simplified this, it's only got 2 servers. Those are the Linux host names, and it's running an Oracle database, it's got some Java code running a web server, and it has an application support group, the blue guys on the right, and it has a bunch of application users who access the web server. If they have problems with the Linux environment, they will go to the Linux third line team because the app team don't support the infrastructure. And that is what is generally accepted our model for a business application on-premise within the business. And what we do then when we extend it is the stuff at the bottom. So you'll see 2 yellowy boxes, has A307 and has AEU308. And these are factory logical containers or security groups within the Hadoop environment where this application has extended itself to. Actually, there's a slight typo on this slide. Those numbers at the bottom that say 12126 should say 654.322, so excuse my typo. But we link the whole lot of all of the servers, all of the Hive databases, the folder directories on HDFS are all bound back to that business application. So we've got a very clear steer who the tenants are on the cluster and what they're doing. And we encourage them to say, this is just put whatever is your application -hx, and that is the has extension. We found 2 yellow boxes there because we quite quickly figured out that you need to keep the guts of the application, so that's the application code and the raw databases and data files separate from the end users. Typically we'll then separate those 2 by a set of table views or relational views onto that Hive database. A few users, power users, will go in and access at the file level, but generally we'll try and encourage application teams to expose into a separate end user group where we manage that. But all of that user identity stuff, passwords, and group membership is all managed in our Active Directory environment. So the whole Hadoop cluster is just a slave in terms of user and groups and authentication to the Active Directory, and that is because we have very robust process. People join BT or they leave BT. There's entire automated ripple-through processes that will revoke all the system's access and manage all of that in line. So it allows us to offload a huge amount of admin into business as usual. And if you want to get access onto the cluster, you just raise an order for an Active Directory account, specifying the Unix, the has group you want access to. And we've had to build none of that. We just reused it on our existing environment. And that Hadoop third line team, and it's yellow because it's actually the same people, that's those 4 guys you saw in the photo running that environment. So if any of the application support groups have problems accessing the what's known as the HUE user interface, that's the GUI, onto Hadoop, or indeed if the app users have problems, they can go to those third line teams and say, I can't get to the login screen, what's going on? So that's a normal support ramp. So let's quickly look in a little more detail at how that works in practice at sort of detailed level. So this is one of the data transfer recipes between the source application database and their HAS extension. So we call it the hop skip because it's obviously a 2-stage process to get the data there. So it's one of our least preferred but most flexible approaches. We use it when applications can't support HTTPFS. So what happens here is that top application basically has a managed file transfer using typically SCP, or if you really must and it's not privileged data, FTP, onto that edge node. So that marks the edge of the platform, and we have a number of resilient edge nodes, and they land their file there, and then the lower box is where they run a Hadoop command, HDFS-FS, and they either put the file up into HDFS or they get a file down for HDFS, depending on which way the flow is going. The reason we don't like this is because it generates, it's obviously slower because it's a 2-hop process, and also it requires good housekeeping on the edge nodes, and when you've got many dozens of tenants, it only takes a few of them to be not meticulous about deleting old files for you to run into space problems on those. So, but that's an easy one. If people want to get going, we sometimes do that quickly if all they can manage is an SCP of a file. The next extension then, our preferred one, is a RESTful exposure of the Hadoop file system. So as I alluded to earlier, we still propose a service-oriented architecture, which means we like RESTful exposures, so we like to use HTTP combined with URIs as our way of identifying resources. So through the gateway on the edge nodes, there's an HTTP file system edge node there. You can cook the URL, which includes your service identifier, and you can then use HTTP to get or put files off or on the Hadoop file system, and between that and your Linux server. It doesn't touch the sides of the edge node, so it's very efficient. It's just basically a network transfer, and you would use a Linux command called curl on the remote system to push to generate the HTTP commands. There's a slight, the biggest hiccup we find is actually is persuading people that they already have Kerberos. Most people don't realise if you've got a Linux box, you've already got Kerberos installed. You just need to edit one config file and run a command called kinit, and that will establish you a ticket, and you can then send data to and from the Hadoop cluster. So, and that's this is our preferred pattern. We got to the point whereby the Hadoop, the Linux admin team, basically go on and set this up in about half an hour on a good day, and we can have data flowing fairly quickly. So that's all file-based access, but really we'd rather go straight database to database, and this is where stuff gets a bit more interesting. Some of you will have heard a thing called Scoop, equal to Hadoop connector. It's one of the most widely used utilities within the Hadoop stack, and we spent a lot of time working on the design patterns around this. I'm showing one here. There's actually about 7 or 8 slides here going into lots and lots of detail about role privileges and access to $$ tables on the Oracle database that we had to spend a long time working with our DBA colleagues on. But the broad process that the way this works is that if you run the scoop command on the edge node, as your client. So you say it's now an hour has elapsed and I want to pull down my next hourly set of data. So we're doing sort of periodic transfers. First thing the scoop job does is connect up and authenticates to the Oracle database and pulls down a bunch of metadata about the database. It looks at the queries to data dictionary and gets the sort of Oracle table IDs, and then it builds a set of parallel queries which it's going to push down into the data nodes and run in parallel. So let's say you've gone to transfer 10 million rows or a billion rows. It will say, I'm going to split that up into 10 queries, each of 100 million rows, and it will push those down onto 10 different nodes, which will then in parallel go back to the Oracle database and connect up, and they will say, I will have the first, one will say I'll have the first 100 million, the next one gets the next 100 million, and so on. And there's quite a bit of tuning to be done to figure out what is the optimum number of parallel connections to be done. In many cases it's one, because the source Oracle database just hasn't got enough capacity to support that. So in most cases we can suck data out of a database, in most cases we can write data to the Hadoop file system much faster than we can suck it out of the Oracle database, even when we're doing simple table level extracts. The transfer is pretty fast. And there's variants of that using change data capture, so we can spot things like changed rows or additions of rows, so time series type data. So that's a common pattern. So that's it. So I probably would just leave you with one of these reference architecture slides. Maybe that one is a good one. Lorne, now I don't know whether we can stretch the technology. There you go. I can see you back again. You disappeared there.
I can even
take any question.
I can even move the camera to where the question comes.
Wow.
So there we go. So fascinating. Thank you very much. A whiz around a really interesting part of BT. So we've got, as planned, about 20-25 minutes for questions. Are there any thoughts or questions from anyone? Yeah.
Just to clarify, extend in this context actually means copy. So we are setting up a copy.
Yes. Yep. So we accept that the master state resides within the relational database, but actually a huge amount of data in BT data is time series data. And so they're immutable facts that are not going to change. So every alarm from every bit of network kit, every test that we do on a copper line is all done at a point in time. So actually, that data large quantities of our data never change state. So you can replicate it safely, knowing that that data is not going to get out of date. And so that's why this type of architecture works well for us, because we have a lot of immutable time series data. Where we have live data, so CRM data, or live network status data, then that stuff does still tend to stay within the relational world today. But as we're looking already with evolutions in the network space, such as the software-defined network or network function virtualization, where the data, instead of being streamed through a relational database, would be streamed through a Spark algorithm, and so the status would be calculated and maintained within the big data platform. And indeed, we have a pilot project that's looking at using a graph schema database, because it's kind of intuitive that if your main construct of your business is a network, so in Facebook's case, obviously it's a social network. In our case, it's a lot of networks of routers and layer 2 switches and layer 3 routers and so forth. We've got a number of some work underway to look at could we maintain live status of entire network within the graph database, and then keep that populated in real time using status from the network, which is something we've never previously been able to do because of scaling issues.
Anyone else? Yeah.
Did this start out as a answer a question solution? And is it still an answer question solution? You put the data in, figure something out, and disappear it, or is it morphing now into a long-term storage? It sounds like you are beginning to become the repository rather than just a query point.
That's a good question. How did it begin? Was a common question. So it probably would go back to that original timeline. Is that it started with the research guys, and the research guys found they didn't want to get caught out again. What had happened previously was that they'd built research projects for the business and found themselves with applications or proof of concepts that the business started to rely on and treat as production systems. And very early on in the piece, Rob and Simon in our research team said, actually, we don't want to get caught out like this again. We want the strategy to get this stuff into a business as usual data center as quickly as possible, so that we know that when we build a proof of concept, if it looks like it's going to be one of those projects that a factory goes into a standard business operational mode in a sustained long term, then they know where they can move the data to and start to build a support team around it. So those guys came to me in about 2010 and said, help, how can we get this downstreamed? Of course, they didn't have any money, but they just said they had an impending problem. And so that was when I started getting engaged. And my first intuition was that this was, as I say, really a data center and infrastructure platform. As I said, it's about data storage, HDFS, and it's about compute, then MapReduce, and now Spark. And so we have an data center infrastructure architect, a guy called Tim, and I said to Tim, I think you should own this stuff. I don't quite know what we're going to do with it yet, but it sure looks like storage to me. We spoke to Anne, who's our storage architect, and said we'd like to include HDFS in the storage portfolio, and we'd like you to run it. By the way, we haven't got any money. And eventually we built the initial investment was basically done. We pitched a case to the TSO, that's the IT leadership team. Clive Selly was the CEO at the time, and said, Clive, you keep hearing about big data and you say you want a big data strategy. Well, you need to stand up to build some infrastructure. Here are some example projects. So we could point to the projects that have been done on research, and so they basically took a leap of faith and after a lot of badgering and several months, invested in the first phase of the infrastructure, which by their standards was quite a small investment. I don't think at that stage, in the sort of sea of projects that we were doing, it was really in the sort of almost at the seed corn funding phase, as we would call it. But it's grown steadily, and it now has independent funding direct from project teams. And you know, we are just in the process. We have a business case in flight to bring in the second site, which will bring on disaster recovery, which will allow us to commit to the business to do operationally critical applications. So, you know, it's now a long-term part of our portfolio. I've got actually another slide which I use to explain to business people really the difference. You know, why do we, if we have a virtualized on-premise cloud, why do we need yet another infrastructure? And the analogy is there as a shipping analogy, one of shipping containers versus bulk carriers. So if you're running a shipping fleet, which is loosely what we call the data centers, then most of the application loads fit nicely within containers, virtualized containers, and we can use the end-tier scaling approach. But in some cases, it's just quicker and cheaper to shift the data in bulk and store it in bulk in big piles with not much structure. And we have a flow chart that actually is used to vet the use case to route it to either a private cloud or onto the Hadoop infrastructure. So it's kind of it's now a long-term part of our estate. It has the advantage that, as I say, we've got those ability to build sand pits on the side of it, and so those are answering business questions is very much a side benefit that we get out of that platform. So you know, it's a multi-function bit, and that's why, from a stakeholder point of view, it's quite complex because you know, we have operational people, we have data center people, we have data science people, and obviously a whole bunch of change control and capacity management people that all need to get on board and understand how to sustain the infrastructure.
Anyone else? I don't know if that works. I might find it easier if you share anything.
Yeah, so you mentioned about governance for access to the data, but if you're looking at, you don't want to stifle any innovation, but you still want to be able to control that process. So is that done manually with your governance team? Or?
Yeah, so yeah, that's still a human activity, and that's what that new analytics governance do. We're actually on governance 2.0 for that piece, and we're probably going to be going to governance 3.0 when I can have a workshop next week with some colleagues to discuss business data stewards. So at the end of the day, we have to help people understand and explain what is the question they're asking, and what data sets do they need. And so there's a sort of an element of onboarding about the governance. So, you know, in practical terms, there's 4 people that sit on the board. It meets on an audio call on a Friday morning. We spend about an hour. We typically will get through anywhere between 0 and 4 cases. We typically will look at 2 or 3 slides, and we'll try and ask the people, and there's a very broad range of people, what is the business question you're seeking to understand? What is the insight you're after? Do you know what data you need? In some cases, they know, yeah, you know, I've already got some of this data through this report. In other cases, they'll go, we're not sure. We think it's on one of these systems. In which case, we'll put them in touch with the right architect to help them track down the data they need. And that, of course, then that may cause a delay in terms of while that application is hooked up. Alternatively, they might actually just take an extract and land the data manually into the sandbox and do their analysis using offline data to prove or test their theory. So, and it's not too much of an overhead. You know, it's an additional responsibility for a couple of architects and a couple of delivery types who keep track of that. It's a SharePoint site where they all get registered, and we bring them back, as I say, for review to check their progress and see how they're going. What we find is that sometimes those business questions find insight that then they want to feed back into the business as usual mode. So we had one last year that was looking at OpenReach field engineer visits and trying to figure out if it could detect when it was trying to find the engineer visits that were a waste of time and what were the indicators, so that we know where we missed something in our diagnostics. And they found some additional things to look at before you dispatch the engineer, which we then took that algorithm and pushed it back into our diagnostics platform. So we had to sort of complete the journey and feed that back into the operational world from the sort of data science world. Did I answer the question?
Yeah.
So Philip, where do you think this is going to be going in the next sort of 3 to 5 years? Are you going to be selling this as a service, or are you going to carry on extending it?
Okay, good. So good. Where are we going? So so it won't have escaped your notice that we have recently completed an acquisition through EE. So we're back in the mobile business. Most of the kind of senior BI and operational managers, particularly the marketing people, now understand that they can see the value in joining up the data sets, and it gets harder and harder as the data sets get bigger. So we have, I forget what the stats are, something like 700,000 TV viewers. We have live TV viewers on a Saturday afternoon in the hundreds of thousands. The ability to stream all of that data, understand which of those people watching the football are watching it on an EE mobile, where they are geographically, all of that stuff. So increasing the integration of the data. Obviously, the primary driver behind the acquisition is to be able to offer quad play, not a 4-play, as one of my French colleagues said the other day. It's a quad play offer, and that means you have to bring very large amounts of data together in near real time. So definitely there'll be more data integration that's going on, and that's about building an integrated data asset that will answer as many questions as possible. Now, the monetization is an interesting topic. We steered away from it early on, and many other people went in completely opposite direction, and the first thing they tried to do is to figure out how they could sell their data. And we've actually now acquired through EE a product called MData, which is the sale of anonymized mobile data. And so that's a project that we're just starting to look at the roadmap for that. But more interestingly enough, I think I mentioned earlier on, we developed, in fact shown there, our BT Saturn UI, and we're now starting to embed the Hadoop stack within our own products and services. So through Global Services, we sell a platform called CyberAssure. So this is sold to large corporations such as banks or enterprises who have networks or infrastructures that they need to protect from cyber attack. And so we have a solution architecture supported by a managed service that we sell. We have a couple of big security operations centers. I mean, effectively, we now have a Hadoop environment that's effectively the core of a managed service platform. In terms of innovation, that slightly leads our internal platform. It already has Spark streaming running on it. They make more use of search as well. They index and search a lot of their data in near real time as it's received. So, and that's ingesting, all the sort of things that you would expect in terms of firewall logs, remote agent logs, traffic flow logs, login, authentication records. All of that sort of stuff is ingested at scale in real time and presented as a console and a dashboard and a tool set to the security operations people, who will then use that to manage threat and reroute traffic and events in the occurrence of a DDoS type attack, or manage that kind of stuff. So we basically, and the teams that run those Hadoop clusters are the same teams that run the internal ones. So we've effectively monetized the skills and reused that capability. So that's GS CyberAssure. We have looked at providing an equivalent service to our internal Hadoop as a service in the cloud. I'm in talks with a number of prospects around that. Some of you may have seen IBM Big Insights are now offering a Big Insights in the cloud, so they think there's a market in it. It's probably, and I get to speak to quite a number of customers as they come through our innovation centre here, and they're all at very different states of maturity. So some of them would be ready for a Hadoop service, and then you get into discussions about, well, would it be on their premise? Would it be in one of our hosted data centres? Certainly the ability to link into their corporate networks that in many cases we run at scale, so with 10 secure 10 gigabit links, makes it a much more viable technology, because if you've ever used Amazon Web Services, you're essentially limited to the internet to the bandwidth connection and the quality of that connection, and it's often described as trying to fill a lake through a straw or half a dozen straws, and that's a very slow process. So in reality, it's very hard to move. Even tens of terabytes of data around takes many hours. and certainly when you get to petabyte scale, then you're talking days and days. So it's even something even Google don't do in any sort of scale is move their data around a lot. They tend to replicate it, the indexes, and move that stuff around. So.
Great, fascinating. We've got probably time for one more question. Anyone?
Yeah, I did have a quick question. Hi, yeah, just a quick question on business justification, really. I mean, there's a huge amount of investment here already. But what measures are BT using, and how do they quantify them to justify kind of continued investment in this service offering? I mean, obviously, clearly, you know, from a customer perspective, they're saying, yeah, I've got a query I want to run, and it's going to be input into our project, and we're going to make a decision. But you know, quantifying those and justifying continued expenditure to your exec, how do you go about doing that?
Yeah, okay, so it's an interesting discussion, so I'll perhaps go back to this one. So the investment we made in that tin was made, whatever it was, over 2 years ago now, and we haven't any more money on it. So in terms of continuing to investment, all we've done is we've told the existing third line team that run the Linux servers, you have to run the Hadoop clusters as well. The big push from us has been into training and educating designers and architects in appropriate use of this technology. So each one of those, and remember the graph we had of the 200 service instances, and the 50 or so projects that represents. Each one of those 50 projects, the Hadoop bit is a small piece of a larger business requirement. So in some of them, they're end of service life ones, so we measure it in terms of our ability to cost effectively keep an application running. So one of our very earliest use cases was a legal entity master data management solution. So a 12-year-old application running on a very old version of HPUX on some hardware that really was long past its end of service life, and to top it all, it was in the data center we wanted to close. So it was an application that we were going to have to spend a considerable sum of money, in the hundreds of thousands of pounds, to re-platform either into another data center or onto the private cloud. And we did a quick proof of concept. We said, well, show us what code you've got already, and they had a lot of PL SQL, and it wasn't very sophisticated. And we did a quick look at, well, let's take a few of those business rules and see if we could port them into Hive HQL. It went pretty well. So we costed that one out, and we found that it was actually cheaper to re-platform the application onto Hadoop than it was to actually put it back onto another Oracle database. So, and also we considerably accelerated their batch time. So they went from close on a 24-hour batch run to an 8-hour batch run, and they significantly increased their data volume. So the business case for that was very clear. The business wants the application to run. It's end of service life. Somebody's got to spend some money. What's the cheapest option? So, that's a sort of freestanding business case. In other cases, there's certainly value in terms of a capability that allows the business to ask questions quickly. So the example I would cite there would be a project we did on nuisance calling, so quite a topical thing. And some of you may have seen last week we announced a network-based call blocking service. Last June, Ofcom came to BT and they went right in at the top. Sharon White, the new leader, CEO at Ofcom, went to Gavin and said, Gavin, we think there's too much nuisance calling going on the telephone network, do something. And Gavin said, I will call our IT people immediately and have them do something. And the CIO of Wholesale said, this sounds like a big data program. And he spoke to the operational people and they said, well, we haven't got enough reports and we don't really know where the calls are coming from. very quickly that ended up in my inbox, and I then bounced it across to the research people and said, well, look, if I get you the data, can you do the data science? And they said, yep. So we spun up an instance on the platform. It took 48 hours to get the security approval. We had 2 billion CDRs downloaded within 3 days. The core of the data science was done over the next 7 days, and that was a couple of guys working on a scoring algorithm, and it's a multi-dimensional analysis that looks at every call in the network and figures out, based on properties of this call, is it likely to be part of a nuisance stream or just a normal call? And now we don't, at that point we were just producing a model, and we've taken that model to Ofcom, and Ofcom are looking at what they might do with the regulation around that. But that was really, I think, one of the first examples where the business suddenly realised that it had a capability that allowed it to do things and move at a speed that previously IT would just have not been able, really struggled to meet a request like that from the so-called JFDI requests from the seniors, and we managed to do that with very minimal disruption to any existing systems or applications. So that's the kind of, there is a capability thing, and I think that is one of the hardest ones to express in terms of, well, what's that worth to the business? Put a pound value on it, and that's something we still struggle with. But having that capability is certainly one of the reasons that senior management, continue to support it as an overall infrastructure.
That's great. Thank you very much.
Yeah, interesting answer.
Yeah, very interesting.
Great. One more?
Yeah.
Well, that's Philip. That seems to round it up. Thank you very much for trying out this new technology. Well, it's not new, but it's new to us. That worked quite well, didn't you? You didn't really feel that you were in a room talking to a screen or listening to a screen. I think it was well set up. Yeah, and I think it shows that we can remote some of this stuff, either in or out. So a warm thank you, Philip.
Thank you, everyone.
We haven't quite developed the technology to shove a present down the...
Right to pull down. What happens if I... I'll catch up with you offline, Lorne. Thanks again, everyone. Thanks, Gustav, for the logistics on that, and I'll say cheerio.
Great. Thanks very much.
Bye.
Bye. Good. Just a few notices. How many enterprise architecture specialist group as opposed to any other group here? Okay, so yeah, slightly under half. Well, welcome those who aren't with the enterprise architecture specialist group. I thought it was a very interesting talk. We run one of these every other month, so the next one's going to be in April, not quite yet decided. I managed to speak to the CIO of the British Council the other day, who has just struggled to hire a chief architect and was telling me her story. So I think if I can persuade her to come along, that could be quite an interesting session. She says the architecture community is being overinflated, mainly by headhunters, and to actually find a real architect is quite difficult. So we might do something around that. But having said that, if you've got ideas, do come and see me. I'm here for the next few minutes, because we're always looking for interesting ideas, particularly people who are sort of doing stuff in reality. That's really interesting. Then in June, there's the Enterprise Architecture Conference in London, the 13th of June, which is something you can either sign up to, but we'll probably be doing, like last year with John Zachman, an evening event on the Monday, which will be in the hotel in the West End, and trying to do an interview as opposed to a monologue, which it was last year. And we'll be running June and then August and every other month, anyway. And committee meetings, for those of you on committee meetings, there'll be one next month, date to be decided. Great, well thanks for coming, and I hope there may be some food still outside, and hope to see you at the next one. Yeah. Double check. And of course, we originally suggested
As you are law official.
I can share it.
Rather as you come on specialists, as you enjoy do you work in this sort of? Yeah, I do confirmation.
I thought it was actually great. I was more data management. I used to work in BT. I started 20 years Yes, it's going to go on. Yeah, we recorded it. The slides will also go
the problem I find is solution.
Thank you so much. That was really well.
Yeah. Okay, good.
Yeah. Well done. Last minute.
Yeah, it'd be nice to get more involved with
Well, it doesn't. I mean,